How castles were built without modern machines. Picture this. A single stone block weighing more than two modern cars, lifted 200 feet into the air by nothing but rope, wood, and human determination. No cranes, no bulldozers, no power tools. Yet, somehow, medieval builders created architectural marvels that have stood for nearly 1,000 years while our modern buildings crumble after decades. How did they do it? The answer lies in a world of ingenious engineering, brutal labor, and secrets that were jealously guarded by master craftsmen who took their knowledge to the grave. The human machines that defied gravity. Before diving into the technical wizardry, let's talk numbers that will make your jaw drop. Warwick Castle's walls contain an estimated 500,000 tons of stone. That's equivalent to moving the weight of 2,500 blue whales, one block at a time, using only medieval technology. The Great Tower of London required 90,000 tons of Kentish ragstone, transported 50 miles by river and road. Each block was hand-cut, hand-carried, and hand-placed with mathematical precision that would challenge modern engineers. But here's where it gets truly mind-blowing. They did it faster than you'd think. Chateau Gaillard, Richard the Lionheart's beautiful castle in Normandy, was completed in just 2 years. 2 years. That's a pace that would impress even today's construction crews, despite having access to machinery that medieval builders could only dream of. The secret weapon? The treadwheel crane, medieval engineering at its most brilliant. Imagine a giant hamster wheel, but instead of a rodent, 2 or 3 grown men walked inside a wooden wheel up to 18 feet in diameter. This human-powered machine could lift stones weighing several tons to heights that seemed impossible. The genius lay in the mechanical advantage. The large wheel turned a smaller axle, multiplying the force applied by the men inside. It was essentially a medieval power amplifier, transforming human energy into lifting capability that could rival modern equipment. The master's secret arsenal. Medieval castle builders possessed an arsenal of ingenious devices that would make Leonardo da Vinci weep with envy. The windlass, a horizontal cylinder turned by handles, could drag massive stones up steep ramps using a system of pulleys that multiplied force exponentially. Archaeological evidence from Guédelon Castle in France, where craftsmen are building a 13th century castle using only period techniques, reveals that a single windlass operated by 4 men could move blocks weighing over 3 tons. Then there were the pivoting cranes, mounted on the castle walls themselves as they rose. These clever devices could swing heavy stones into precise positions, eliminating the need to build massive ramps to every corner of the structure. The crane operators developed an almost supernatural sense of balance and timing. One wrong move could send a multi-ton block crashing down, potentially killing workers below and setting construction back months. But perhaps the most ingenious solution was the counterweight trebuchet repurposed as a construction tool. Yes, the same machine designed to hurl boulders at enemy walls was occasionally used in reverse, with its devastating power harnessed to lift building materials. Imagine explaining that to your insurance company today, the underground empire you never knew existed. Here's something that will fundamentally change how you see medieval castles. What you see above ground is only half the story. Beneath every great fortress lay a hidden world of foundations, cellars, and tunnels that required engineering skills bordering on the supernatural. Take Windsor Castle's foundation work. Medieval builders had to excavate through solid chalk bedrock without explosives, using only iron picks, wooden wedges, and fire. They would heat the rock face with enormous bonfires, then douse it with cold water, causing the stone to crack along natural fault lines. This process, called fire setting, was borrowed from Roman mining techniques and required master craftsmen who could read stone like others read books. The precision of medieval foundation work defies belief. At Caerphilly Castle in Wales, builders constructed foundations that perfectly follow the contours of an artificial island they created by damming local streams. The engineering calculations required to ensure the foundations wouldn't sink into the marshy ground involved mathematics that wouldn't be formally documented for another 300 years. The guild secrets that died with their keepers, medieval stonemasons operated under a veil of secrecy that would make modern tech companies jealous. They developed their own languages, symbols, and closely guarded techniques passed down through generations of apprentices. Master masons carried in their heads the geometric formulas needed to calculate load-bearing requirements, arch proportions, and structural stability, knowledge that was never written down and died with them. These craftsmen could look at a quarry and instantly identify which stones would be suitable for foundations, which for walls, and which for decorative elements. They understood the directional grain of stone better than modern geologists, placing each block so its natural strength aligned with the structural forces it would bear. This intuitive engineering meant medieval castles were often stronger than the sum of their parts. The masons' marks carved into castle stones weren't just signatures, they were quality control systems. Each mark identified not just who cut the stone, but when, where, and to what specifications. If a wall section failed decades later, investigators could trace the problem back to its source with forensic precision that modern construction rarely matches. The logistics nightmare that somehow worked. Coordinating a medieval castle construction project makes modern supply chain management look simple. Master builders had to synchronize the delivery of materials from dozens of sources across hundreds of miles, all without phones, computers, or even reliable maps. Consider the construction of Caernarvon Castle. Edward I's builders needed limestone from Anglesey, transported by ship, sandstone from local quarries, moved by ox cart, timber from Welsh forests, floated down rivers, iron from the Forest of Dean, carried 150 miles, and lead from Derbyshire mines, transported by packhorse. The timing had to be perfect. Stonemasons couldn't work without material. But storing too much inventory was expensive and impractical. The solution was a network of specialized foremen called purveyors, who managed regional supply chains with military precision. They negotiated with quarry owners, arranged transport, managed quality control, and coordinated delivery schedules that would challenge modern project managers. All of this was recorded on parchment ledgers that reveal logistical sophistication that wouldn't be seen again until the Industrial Revolution. The brutal mathematics of medieval labor, the human cost of castle construction was staggering, yet the efficiency achieved through pure organization was remarkable. A typical castle employed 2,000-3,000 workers during peak construction, 200 stone masons, 400 carpenters, 1,000 general laborers, 200 quarrymen, and hundreds of specialists including plumbers who worked with lead, not water, glaziers, smiths, and painters. These workers were organized into gangs with specific responsibilities and productivity targets. Surviving records show that skilled masons were expected to cut and place 2 to 3 tons of finished stone per day, a rate that included cutting, shaping, and positioning blocks with millimeter precision. The penalty for poor workmanship wasn't just dismissal. It was professional ruin, as the mason's mark would forever be associated with inferior work. The engineering miracles hidden in plain sight. Every medieval castle contains engineering solutions that modern builders are only now beginning to appreciate. The walls weren't just stacked stones. They were complex composites with rubble cores held together by lime mortar that actually grew stronger over time. The mortar itself was a chemical marvel. Lime mixed with sand, water, and secret additives like egg whites, blood, or beer that enhanced its binding properties. Castle builders understood concepts like thermal expansion, wind loading, and seismic stress centuries before these became formal engineering disciplines. The slight inward lean of castle walls wasn't aesthetic. It was calculated to redirect gravitational forces and resist battering ram impacts. The spiral staircases that wound clockwise weren't arbitrary. They gave defending right-handed swordsmen an advantage over attacking climbers. Perhaps most remarkably, medieval builders achieved all this while creating structures of breathtaking beauty. The same craftsmen who calculated load distributions and stress points also carved delicate stone tracery and created soaring spaces that inspire awe 8 centuries later. The next time you see a medieval castle, remember, you're looking at humanity's greatest construction achievement. These monuments were built by people who moved mountains with muscle power, solved engineering problems with pure intelligence, and created lasting beauty with hand tools and raw determination. They had no CAD software, no steel reinforcement, no power tools, just knowledge, skill, and an unshakable belief that the impossible was merely difficult. In our age of GPS-guided bulldozers and computer-controlled cranes, perhaps the most humbling realization is this: they built better, stronger, and more beautiful structures than we do today. The masters who raised these stone giants are long dead, but their greatest secret remains carved in stone for all to see. That human ingenuity, properly applied, can quite literally move mountains.